So today, I will share you our story of pursuing the vision of integrated database. And And so far, we have designed a database that can be utilized in many different ways. The database is already being in use for several purposes, and we are now expanding both the range of data and its applications. And we are still in the middle of the long journey, but I believe we are in the good place. And our strategy is based on in-house system development by on-site researcher team with IDBS Spreadsheet as a core platform. So especially, I will explain why building integrated database is so challenging and why a scientist-led approach works well. So before going to the detail, please let me explain about Chugai and myself. So Chugai is a Japanese pharmaceutical company, and we are a member of Roche Group. But today's presentation is not related to Roche activity. It's our activity. And we are placing strong focus on digital transformation. And about myself, again, I'm Yuya Ishikawa from Chugai, and I am the one who experienced and understand both laboratory and digital products development. And as my career, I joined Chugai as a wet lab scientist for cell line development. Originally, I had no IT background and skills at all. But after a while, I started a laboratory automation project for cell line development. And while working on this, I realized that the important thing, the real system only works when that is designed with deep understanding for domains. So that experience motivated me to learn digital skills, and I started to learn digital and develop in-house products using programming or machine learning and application engineering. And now I'm focusing on this project, building integrated database. So let's go back to the main topic of integrated database. So in this slide, the vision of integrated database and its reality are compared. So the integrated database is a database that can store many different types of data, eventually any data. And you can use that database to various kind of applications. So this is basic vision of integrated database. And it sounds very attractive. But and many companies pursue this vision, I think, and we pursue as well, and IDBS help us. But the reality is not that simple. So at least there is no such magical stuff. So we need to design data structure meticulously, because that limit the application range. And also, the important thing is the users have to input data into the database with that structure precisely. So in daily operation, so that is the core challenge. The core challenge is capturing high quality and well-structured data at the laboratory bench. The question is how we deal with this challenge. So this slide shows a general flow of building integrated database. First, you need to specify the purposes of use cases. For integrated database, the purposes should be so many. So you may have to limit or prioritize those purposes. And after that, you need to design the data structure so that the use cases can be achieved. So this designing data structure is one of the key, because as I said, it determines the application range. And after that, you need to design and develop and operate the data input system and operational workflows. The workflow should be good enough for users to follow, because the users have to integrate this workflow into their daily operations. Once you get structured and large amount of data, you can utilize it. And in order to follow these steps, you need deep domain understandings. While you need some digital skills for database and engineering, I think the true key to success is domain understanding. In particular, research environments in pharmaceutical companies are highly complex. You need to consider not only their research, but also their operational practices and organizational culture, regulatory, so many things to consider. So this complexity is exactly what makes building integrated database so challenging. So our approach is like this. Oh, sorry. So the first, overall design, development, and adaptation is carried out in-house by domain scientists themselves. And second, IDBS spreadsheet, using IDBS spreadsheet as data input agent. Let me explain further for the first one. As I said before, the key is the domain understanding. And this approach is direct answer, because they understand their domains. And sorry. And if developers are domain scientists, they can capture what end users really want. And they can support them in the same laboratory. It's easier to adapt in the real laboratory. And second one, using IDBS spreadsheet, basically we want to assure the structuring the data using spreadsheets while recording experimental notebook at the same time. And because using this spreadsheet, we just replace their daily experimental notebook, and we don't have to give them additional tasks for inputting data into the database. So it's more acceptable for users and easy to adapt in the laboratory. And of course, it is also important that this system is pharmaceutical grade. Okay, to do this, we gathered scientists from each laboratory in bioprocess and made up a team like this. I am leading this team, and there are 4 different subdomains: laboratory, cell line development, cell culture process development, and purification process, and analytical. We have broad range of scopes. We design the use cases, and we design data model, operational workflows, and spreadsheets as data input format. And we develop them the spreadsheets, and data utilization applications by ourselves. And also, important thing is we drive adaptation by ourselves in the same laboratory with users. So to do this, we need to be capable of both for domain and digital. So as we are belonging to the laboratory, we know about domain. We know about experiment, about their science, current operational workflows, and regulations behind that. And also, we need some digital expertise for this project, especially for relational database and building spreadsheets. So this is a challenge because typically we are just wet lab scientists and we didn't have enough IT capabilities. So we need to develop not only products but our skills at the same time. And to do this, the vendor support is also important. So when you are outsourcing, so it's kind of different type of support from vendors compared to asking outsourcing to vendors, because we ask them more technical things, more detailed things to know, to develop by ourselves. Okay, and let's imagine how things go with our approach of internal development. So let's say we are development team in the laboratory and users are our colleagues. And users, and we are in the same lab, and we develop and release product to users next to us. And they are using the product next to us. And when they have questions about our product, they can ask us immediately, and we can quickly answer to the question. And also, if something like if they want to make the product to improve, they can tell us honestly, quickly, and we can discuss them with high context. And we can immediately start to redesign the workflows and the products. So, and we can repeat this cycle, feedback and refinement, again and again, to improve our products and operations. I think this makes the product completion of the product faster and more valuable, and we can make users more understanding. So I believe this is the best way in our case to adapt spreadsheet into our laboratory. And until now, I focused on to explain how we deal with our strategy. And from now, I will explain a part of our achievement. So this slide shows the end-to-end data flow from laboratory bench into applications. Now we have built and operationalized an end-to-end data flow from spreadsheet as a lab bench to multiple end-user applications. On the left side is laboratory bench where data are generated. So users first generate the data and then immediately input the data into spreadsheet as their experimental notebook. Then we can assure the structure of data. Our data platform or data warehouse pulls the data from E-WorkBook. Then the structured data are stored in our data platform, and it is ready to use for applications. And this architecture itself is also important, but as I said before, the truly important thing is how we design the structure of data and how we assure the data input from users. In this slide, I mentioned about the design of data model. Unfortunately, I can't show you the exact structure of our data model, but we have designed well-structured general data model for bioprocess development that can link information between samples, processes, and results from very upstream to downstream of bioprocess. And the challenge was, as we expected, there was too many requirements to deal with. So we had to discuss all the time, and it takes more time than I expected. And the size of our database is like, for bioprocess only, 50 to 100 tables. So it is too complicated for end users, but developers understand about this database. And here is about spreadsheets. So we have developed spreadsheets that function as both laboratory notebook and database entry interfaces. So here's an example. The example shows the first you input CSV file into the spreadsheet. Typically, it is a file from instrument of laboratory. And you define relationship between results and samples using guided selection. And typically, the option of the selection comes from different spreadsheet that generates sample information. So because the feature of a spreadsheet is that they can input and retrieve data from database, it can possible. And we can, of course, automate calculation for daily experiments. As a result of repeated feedback cycles, as I showed before, the spreadsheets are now aligned with actual laboratory workflows and getting very intuitive for users. This is a very important point. And once you have structured data available, we can utilize data. So we have three different categories, mainly three different categories of data utilization tools. One is web application. And this is very flexible and easy to share option for data utilization. And nowadays, it's becoming easier to develop web application for web application because of some great frameworks and generative AI. So the scientists like me can develop web application by myself. And if we want to ad hoc analyze data ad hoc or explore something by playing with data, the analytical environment should be fine. And typically, scientists want to use Python. So we have Python environment that is connected to our data platform. And the BI is also a powerful tool that some core users really love. It can easily aggregate and visualize data in the large scale. Oh, sorry. Oh, And additionally, I would like to show you a alert notification system to assure data quality. So in this system, here you can see batch alert notification system in the bottom of the slide. And the system continuously check if the data has some issues. So I'll explain why doing this is valuable. Because even if we support users, or even if we create great spreadsheet, users still make mistakes, and that violate our database. So we need this system to alert users to fix data immediately. So this system always checks the database, and if they find an error, the system immediately sends users a chat message via chat tool, and the users have to fix the data based on that alert. Then the data in the data warehouse will be fixed. So this alert enables immediate feedback and fix, but not only for that, they can learn from this alert. So I said they made mistakes or they misunderstand something, but they can learn what to do with this alert system, and they reduce the frequency of mistakes. So this is, I think, very good too. And another thing is, if there are so many the same type of alert, it should be the defect of our spreadsheet. So we have the users get a chance to learn about spreadsheet, and we also, developers also get to know which part of spreadsheet might be not good to improve. Finally, this slide summarizes the challenge in our activity. As I mentioned earlier, reality is complex. This is not something we can change. And because of that, we need to deal with various requirements. This fact is what makes building integrated database so challenging. And as we proceed, new requirements evolve all the time, making the situation even harder. To deal with that, we need extensive discussion and alignment. We might have taken much more time for discussion rather than developing. So, yeah, it's true. So, but this is something we have to deal with to do this. Very important point. And without this discussion or alignment, we cannot create a truly effective database. And we have another issue that, another problem, like we often face unforeseen issues during development. So one of the reasons is the lack of our experience and skills for IT. Because we are wet lab scientists, we have limited experience and skills. So, but I believe we can overcome the situation by continuous discussion and learning through iteration and improvement step by step. So now our team of members getting very better and better for digital skills and understandings. So situation is getting better. So we will keep doing this. For future plans, we will expand in-house spreadsheet to cover a broader range of bioprocess experiments, and we continue refining data structure, spreadsheet, and applications to support expanding set of use cases. And I hope we can share further progress someday, somewhere. For summary, we are achieving an integrated database. Achieving an integrated database requires rigorous design of use cases, data structure, and data input workflows at the lab bench. And deep domain understanding is the key. So the scientist-led approaches are effective. And by using IDBS Spreadsheets as a core platform, we integrate the structured data capture into scientists' daily workflow, and we have begun realize key use cases. So this is almost ending. So please remember the core value of this presentation. Integrated database succeeds only when data is structured at lab bench. And also, domain scientist-led approach enables speed, quality, and adaptation. I will acknowledge everyone who contributed to our project, and that is all my presentation. Thank you very much.
Thank you. So we have some time for questions. Are there any questions for Ishikawa-san? There's a question over here.
Thank you for your presentation. I just had a quick question. So I think in your diagram you showed that so you upload your CSV file, which is like generated from an instrument normally, right? And you're kind of organizing the data, calculating it in a spreadsheet. Then you're actually pushing that to the catalog database through IDBS, or you're sending that directly to like a data warehouse in your SQL database and everything?
Basically, we store data in the catalog database like this. And yeah, it's not directly to the data warehouse because we use this data in another spreadsheet. So it needs to be in catalog database if you want to retrieve data from another spreadsheet.
So you're tagging all your data in the catalog database before you're moving it to the data warehouse?
So catalog database first, and after that, it's go data warehouse.
Okay. Thank you.
Thank you.
There's another question over here, Stephen. Oh. Well.
Thanks for the presentation. Just got a quick question about the data warehouse. How difficult was it to do? And obviously had some challenges there. What would you do differently if you could do it again?
So can
The data warehouse.
the warehouse.
How easy was it to do?
How easy?
How easy?
How challenging? How long did it take?
So this function is based on the getting data is via web API, REST API of E-WorkBook. So I took months to understand API, but if you understand API, it's not so difficult to get data.
There's a question at the back. It's Tom.
Thank you for the presentation. Very good. My question is more when you're talking about the error checking.
Okay.
And, validating the data. Did you use tools within the spreadsheet itself, or did you use an external program?
Not the spreadsheet function. This is a framework called Airflow, as shown here. Airflow as framework, and yeah, they're referring data in the data warehouse. So
there's another question here.
So we use something very similar, getting data into centralized data spot. But as scientists, we're not always dealing with structured data. So for example, we like to attach maybe those instrument files or annotated gel images. one piece of data that we haven't really solved to extract to get it to a centralized place. Do you guys have plans for that, or do you guys have something similar?
Okay, and we are thinking that we haven't implemented that not structured data into spreadsheet, but we are thinking that such data are directly input into the database with key, foreign key, so we can utilize the data, but it's not have to be input into spreadsheet, everything.
Thank you.
Any other questions? Yes, there's a question over here. Sumit, thank you.
Thank you very much, Tom. I was interested when you mentioned discussion. The discussion is being very important and also taking a lot of time.
Yeah.
And we had a very similar experience. And in the same way, we got better and better over time in doing this. So, in retrospect, what would be the top 3 things that could have accelerated those discussions from day one? Training or some kind of a tool that magically translates an end user request or requirement to what a developer understands as what they need to make.
Okay, so my team, I will show about my team. And there needs someone who understands both sides of domain and technology. And the thing, because I was from cell line development group and I know about cell line development and digital stuff, so I can translate between them, right? But I couldn't do that for cell culture or purification or analytical. So at first, there were no right person for that, but now this team member improved their skills and understanding for digitals, and they can translate users and developers. So that was very key and important to make progress for the discussion. So recently, it's getting more smooth, but at first, it was hard to proceed.
Okay, we have time for maybe one more question. Are there any more questions? Oh, yes, Jennifer.
Very nice presentation. Thank you. And to echo Dan's comment and to sentiments from presentation, similar situation. You mentioned that you followed the agile kind of method to develop requirement gathering, spreadsheet development, user testing, and then back, more of a loop. Did that improve over time? And did you have to do less iterations? Or was it kind of a continual process and you were still honing in on optimizing that workflow?
You mean how the workflow of how we develop?
Mm-hmm. And
Yeah.
to put more context into that, so we adopted more of a waterfall approach for our development. Agile seemed to be more appropriate, so taking learnings from others in this situation.
Yeah, we're changing the method of development, and one day we employed the method of Scrum, and yeah, that was good decision to proceed with. While the Scrum method takes more time to discuss, right? So it was one reason that we take too much time to discussion, but it was necessary. Yeah. Before that, we more focused on developing itself, but after that, we more focused on discussion.